is a software engineer from Nucleus, a software engineering company based in Lesotho, Maseru. So today we are going to focus on building a POS, and we are going to follow through, or at least try to follow through all the software engineering practices, well, at least good ones. So the first thing we are going to look into is SDLC, software development lifecycle. Let's see what that really means. SDLC. Okay, so ChatGPT says the software development lifecycle is a process used by the software industry to design, develop, and test high quality software. The SDLC aims to produce a high quality software system that meets or exceeds customers' expectations, reaches completion within times and cost estimates, and is efficient and maintainable. Here's an overview of the main phases is in the SDLC. First one is planning, and where within planning lies objectives, activities, and outputs. Then the second one is requirements gathering and analysis. I love this one. And the first thing within this is objectives, where we gather detailed requirements from stakeholders. That means that we try to understand what the stakeholders really want and how they want us to carry out what they brought on the table. And then the activities, requirement elicitation through interviews, survey, and document analysis. We go there, they give us some of what they already worked on. We try to understand what they really want and to try to see how feasible what they want is. And then the output would be requirement specification documents, both functional and non-functional. That means when we are creating requirements documentation, we are going to end up with a document where we have functional requirements and non-functional requirements. And then the second step is going to be system design, and the objective of a system design is to translate requirements into a blueprint for building the software. That where comes the graphics designers, or you as a software engineer with a good eye. You want to prototype this whole thing. You try to give yourself a picture of what the final product of this whole thing is gonna look like, so that at least when you start shaking, when you start dropping it off with your development, you know exactly what you are trying to achieve. We are going to do this thing. And then the output of a system design would be a design document including system architecture, data models, and the interface design. That means after you have designed the whole thing, you want to have a document where that states clearly what your software or your system architecture is going to look like, your data models, how you are going to build the whole design of the database, and the interface, how the whole thing is going to look. Not just that, but even the technology stack that you are going to use, right? Okay, and then the fourth one would be implementing or coding. And then the objective of coding, well, it's in your line of work, it's to convert the design into a functional software system, right? And then the activities within this coding, unit testing, code review, and integration of modules. And then the output is going to be a source code and the unit test results. And then after we are done with the coding and making sure that the whole system is into place, we have to test this whole thing. And then the objective of testing is to ensure the software is free from defects and meets the requirements. Do you remember what we created from the onset? That what the stakeholders really want. We make sure now that we just did not create a software that falls within what we want, but falls within what is needed out of us. And this is very, very challenging, because more often than not, you just think you understand a software, you understand what you want, but you don't have any written down document, and that is really wrong. There's a saying in software engineering that written is greater than spoken. So that means regardless how much you think you know something, you really have to have it down on a paper. You have to have it down on your requirements document that this is what you are trying to achieve, rather than just thinking that you know what you want to achieve at the end of the day, right? It's very important. So the output of testing, you're going to have your testing plans, your test cases, test scripts, defect reports, and tested software product. Imagine you rolling out with a tested software product. And most of us as developers, and most of you developers, as you have the tendency to think that everything works just because you feel like it works, and it definitely does work because it's gonna work within your line of work. I mean, you're the one who created it. You're not really gonna test it as much as it's supposed to be tested. You're gonna test it because you know how like the user journey is. You know the you know pressing a certain button is definitely gonna work, but you're not definitely gonna do something that you know is gonna crash your application. So testing this is like really important. And then the last step, okay, not the last. The sixth step would be deployment, and the objective of deploying your application would be to deliver the system to the user or on the production scale or just on a production environment, right? The activities that falls within deployment, installation, configuration, and deployment of the software. By installation, we mean if it's a mobile app or if it's a desktop app, you would have to install it or make it an executable so that at the end of the day the users can install this thing on the devices. If it's a web app, you deploy it, you make it available within a web domain, yeah. And then configuration, that would mean, yeah, installing it, you are going to have to set some few things. If it's over the net, you're going to have to configure some servers, environment variables, and deploy, and the deployment of the whole software. It's falls within the very same line. And then the output would be a deployed system with the user manuals and the deployment reports. And then finally, you are going to have to maintain this thing, and the last step in SDLC is always iterate and refine. Iterate and refine. That's what the Agile methodology tries to stress. And we are going to go through different methodologies in software engineering, and we are going to see how and why the Agile methodology is actually the best approach. So maintenance, the objective of maintaining a software that you recently built or you long ago built is to correct issues, to improve performance, and update the software as needed. The software always have to meet the changing environment of its users. Today we need 1, 2, 3, and 4, but tomorrow we may not need that 1, 2, 3, and 4, or even if we may need it, but we do not need it in the same manner in which it existed yesterday. We need it differently. Okay, and then the activities within maintenance could be or are bug fixing. That means yesterday someone reported a malfunction in your system, and you have to continuously work on that thing and make sure that there are no bugs. Performance tuning, that means it takes a long time to respond. It just does a long thing more than it really supposed to do, and it really irritates the users or even you on your end. It's just not performing very well. And implementing new features, like improving upon what you already built, what you look towards building as your first deployment is usually MVP, minimum viable product. That means you are going to scale from what you initially gave to the audience or to the industry to something that meets what you really want, adjusting to the environment. Okay, so they say SDLC models. There are several ones used to manage the software development process. Some of the most common models include Waterfall model, a linear and a sequential approach where each phase must be completed before the next begins. Okay, a waterfall model, it usually it's more of how people within building industries, infrastructure builders, like how do they work, how they have that procedural thing that they have to follow, protocols that they have to follow. Well, it's something like that. And waterfall is actually it's actually the first one, I think. Yeah, it's the first model where software engineers build this thing entirely on. They would build software based on this thing, and It usually follows requirements gathering, understanding everything, and then the design. After the design, you develop. After developing the whole thing, you test it, and then after testing the whole thing, you deploy it. But the agile methodology, like the issue of this thing often is you are going to work on a lot. You're going to have extensive deadlines, because I mean you have to have really 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 clear requirements, because once you are done with the whole thing, you cannot really go back to it. That's why it's called waterfall. Once you go down, you cannot go back. There's no going back. Once you are done with requirements gathering, you cannot go back. You cannot iterate and refine. You just do that one thing specific, and you have to do it. And then the agile model came through in 2000, trying to address the issues that waterfall model had. And that's why we are going to use this one. It's a good approach. It's what everyone is using today, and there are a lot of different ways of going about agile methodology, like Scrum, which is the most used one, and it's very okay, that we are going to discuss today. Okay, so an agile model is an iterative approach that promotes adaptive planning, evolutionary development, early delivery, and continuous improvement. You remember how we said maintenance, iterate, and refine? This works towards that thing that, like regardless how deep we are within the development, we can always go back to the stakeholders, ask them, is this what you wanted? If not, we iterate and refine. We refine. Okay, this is what you didn't want. We remove it. We add something in. We add that to our documents, to our requirements documents. We fix some few things, rather than just having that one thing and poof, like you go through the whole thing just like that. Yeah. Yeah. Well, we are just going to speak about this too. So let's go deeper into what is agile model, so that after we speak into what is agile model methodology, we are going to create some requirements of our own of what we want our POS to be like. Okay, so agile model. Agile model. Let's say explain this deeper. Okay, they say the agile model is a software development methodology that promotes iterative development, where requirements and solutions evolve through collaboration between cross-functional teams. That means you have your design team, you have your requirements gathering team, you have your developers. They all work together to make sure that whatever they really want is okay. Like they go back and forth. It's not just okay, I heard what the requirements model does, now I just have to do that. But it's a continuous thing. It can change at any given time, as opposed to how it was yesterday, and today it can wake up differently, because I mean we are working within an environment that evolves, so our requirements have to evolve. Well, yeah. And then it values customer feedback, flexibility, and rapid delivery. Here's a deeper look into the agile model and its principles, practices, and frameworks. Okay, the agile principles. The agile model is based on the Agile Manifesto, which outlines 4 core values and 12 principles. The first core values are individuals and interactions over process and tools, emphasizes the importance of people and their communication over rigid processes and tools, working software over comprehensive documentation. Thank you. Focuses on delivering functional software rather than the extensive documentation. We don't want to give you what a documentation says, we want to give you what really works. No? And then customer collaboration over contract negotiation. Prioritize ongoing collaboration with customers over strict contract terms. That means we have to be flexible, responding to change over following a plan. See how we said within your requirements gathering, your requirements documentation, anything can change at any given time. We want to respond to the changes and follow over following the plan. We can always have a plan that can fall back at any given time, but doesn't really, address our needs, our problems. So if it doesn't address those, we cancel it, we put in something that works. Encouraging adapting to changes quickly rather than adhering strictly to an initial plan. Facts. And I feel like we, like the principle of this is just really clear. We have something that seemed to work back then, but it doesn't just work now. So we have to change and make sure that we have something that works. 12 principles. The first one, customer satisfaction. Deliver valuable software early and continuously. Welcome changing requirements. Adapt to changing requirements even late in development. Frequent delivery. Deliver working software frequently from a couple of weeks to a couple of months. Collaboration. Developers and business stakeholders work together daily. You know how I often say, software development is just a means to an end. It's just communication. Software developers are here to actually help businesses or to help any industry, like the healthcare. What we do is just to help other facilities to do that stuff daily. It's We don't know anything aside from making what they want come to true. Like to simplify their jobs, to automate their jobs. That means we need to know the business operations as much as we can. Like we need to know those. That's why, how do you know something that someone works within if you do not collaborate with that person, if you do not work hand in hand with that person? It's crazy. So you cannot expect yourself to be a good developer if you are just seated in the house saying, okay, I'm very good at programming. Okay, you are very good at programming, but are you giving us something that works? Are you giving us something that we need? No, you cannot. I mean, how can you even think of such a thing? So, if you are a software developer within the Agile methodology, you have to constantly be in contact with your stakeholders, your business people, your customer. Know exactly what this person wants in and out. He should be here telling you, no, you are wrong, Shao. Shao is my saying name, by the way. You are wrong, Shao. You should have done this way. I want this thing operating this way. Do it work this way. And at times it's not nice to be told that you are wrong, but at the end of the day, you have to give what the customer wants. And the only way for you to give this person what they really want is for them to be there all the times. Yeah? Okay. 5. Motivated individuals. Crazy. Build projects around motivated individuals and trust them to get the job done. This is very important. You cannot have anyone who doesn't even believe in what he's doing. He's just going to do it for the sake of doing it, and he's not going to give him the energy or anything. So before anything, you have to educate your team how important what you are trying to do is. They should understand that this thing is like really, 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 really important. That way you give them the energy, you give them anything that they thrive, the power to actually want to carry out this thing. Because like skill, it's not just enough to carry out anything. If you are not motivated to do anything, well, you are going to burn out as soon as possible. So you really want to stay motivated to doing this thing, understand the importance of this thing, understand the the value of this thing, so that at the end of the day, when you walk into this thing, you walk into it not just by making sure that it's a working prototype or it's like you are done with your work, but the love for what you're doing. You have to stay motivated. It's a must. Okay, so face-to-face conversations. Put the work aside. Just understand like what the person you are trying to communicate with. Understand this person. Put computers aside. Put your programming aside, and let's communicate. Let's hear what are we really trying to do. Okay, the most efficient way of conveying information is face-to-face conversation. Working software. The primary measure of progress is a working software. So you want to put out a working software as soon as you can, so that at least the rigorous back and forth of you talking to or you conveying your software to your stakeholders is more often. Give them your working software so that they can tell you, no, Shao, I want this way, as soon as you can. Sustainable development. Maintain a constant pace in definitely I bet technical excellence. Continuous attention to technical excellence and good design enhances agility. Simplicity, minimalism. It's the best. Simplicity maximizes the amount of work not done. Simplicity is essential. Self-organizing teams. The best architectures, requirements, and designs emerge from self-organizing team. Work with people who do not need managing. If anyone needs to be managed, here's an expense. Work with people who are self-managing, because that way you know that this goes back to the point of stay motivated. Motivated people know how to organize themselves. Have organized teams so that you know for sure the time that goes into managing is very less. These people are the people that you can really work with, even if you are not working with. That's why they often say the best software development team is the team that has the less people, because we get to have a more organized team and carry out decisions more faster. Reflect and adjust. At regular intervals, the team reflects on how to become more effective and adjust accordingly. Okay. Agile practices. Within the agile practices, we have agile methodologies encompasses various practices to facilitate iterative development and continuous improvement. 1. User stories. Short, simple description of features from the perspective of the end user. Backlog. A prioritized list of work for the development team derived from the product roadmap and its requirements. Iteration. Sprints. Short, time-boxed periods, usually 1 to 4 weeks, in which a specific set of work must be completed. We are going to work on this one today. Daily stand-ups. Short daily meetings where team members discuss progress, plans, and implements. Sprint planning. Meetings where the team selects and commits to the tasks for the upcoming sprint. Sprint review. Meetings at the end of a sprint to demonstrate what has been accomplished. Sprint retrospectives. Meetings to reflect on the past sprint and identify improvements for future sprints. Continuous integration and continuous delivery. CI/CD. This is like very important one. Continuous iteration and continuous delivery. That means you continuously have to change, and you continuously have to deploy, have to give out a working prototype. CI/CD. Very important. Practice that emphasizes frequent iteration of code changes and automated testing to enable rapid delivery of the software. Okay, we have Agile frameworks. Several frameworks implement Agile principles and practices, each with its unique approaches and focus. Scrum. Roles: product owner, Scrum master, development team. So in a Scrum, it's a must for us to have a product owner and a Scrum master and a development team. And then we have the artifacts: product backlog, sprint backlog, and increment. And then we have ceremonies, sprint planning, daily Scrum, sprint review, sprint retrospective. And then we have the focus. Provides a structured approach with defined roles and ceremonies to facilitate iterative development. Okay, and then we have the Kanban, which says principles: visualize your work, limit work in progress, enhance flow. Practices: use Kanban boards to manage workflow, focus on continuous delivery, and focus emphasizes visualizing the entire process and improving flow efficiency without specific roles or time-boxed iterations. And then we have extreme programming, or XP. Practices: pair programming, test-driven development, TDD, continuous integration, refactoring. Focus, enhance enhances software quality and responsiveness to changing customer requirements through technical excellence and frequent releases. And then the fourth one, lean software development. Principles eliminate waste, build quality and deliver fast, respect people. I love this one. Respect people, optimize the whole. Focus adapts lean manufacturing principles to software development, aiming to deliver value efficiently. And then we have the benefits of agile methodology: flexibility and adaptability. This is what makes it very different from the waterfall model. Agile allows for changes in requirements even in late development processes. Customer collaboration, continuous feedback from customer ensures that the product meets their needs. Frequent delivery, regularly delivering working software increases customer satisfaction and reduces time to market. Transparency and visibility. Regular meetings and updates keep stakeholders informed and involved. Improved quality. Continuous integration and testing ensure the defects are identified and fixed early. Okay, here are some few challenges of an agile methodologies. Cultural shift requires a significant cultural shift within an organization to adopt agile principles fully. Facts. Scope creep. Flexibility can lead to scope creep if not meshed properly. Team collaboration requires a high level of collaboration and communication within the team. This sounds easy, but it's very difficult. It goes back to my point, which says the best teams are the teams that are highly motivated. You know how easy it is to talk to people who are really motivated. You don't even have to think about talking because the talking is kind of spontaneous. It happens because it has to happen. Okay. Experience and training. Teams need proper training and experience to implement agile effectively. So the agile methodology is like very, 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 very important. I mean, this is the only way that teams can actually collaborate, can actually work together. Understanding the importance of this thing and fully utilizing this thing, this power, this skill, this tooling can make a very successful software engineering team. Because I mean, without this, it's like working on an intuition that you are the best, and at the end of the day you'll come up with what you really want without even following in other principles. Okay, in summary, the agile model is a flexible iterative approach to software development that emphasizes collaboration, customer feedback and rapid delivery. It requires a cultural shift and disciplined practices to be successful, but offers significant benefits in terms of adaptability, customer satisfaction and product quality. I mean, that's the only thing that we want. Okay, bet. On the next topic, we are going to build our agile methodology, or the whole thing. But more than anything, we are going to step into the first step in SDLC, which is requirements gathering, understanding our product, what we really want, and then after we have that requirements model, we will go on the first approach, use the Scrum framework of Agile methodology to develop our POS.